This video is on the objective calculate and interpret the confidence interval for a population mean with a known standard deviation. Alright, so this means that sigma is known, right? The population standard deviation is known. And this is number 2. Alright, so I've done a video on a problem like this before, so I might go through this one a little more quickly and just straight to formulas and how do we find confidence intervals. All right, so let's get to it. So here's again, if you're unfamiliar with the objective, please click on more instruction and read the notes they have, watch the videos, read the examples. Maybe that'll help you out. All right, so suppose scores of a standardized test are normally distributed and have a known population standard deviation, so that's sigma, of 11 points, and an unknown population mean. So a random sample of 15 scores is taken and gives a sample mean of 101 points. So find the confidence interval for the population mean, for mu, the unknown population mean, with a 98% confidence level. All right. So here, I'm just going to jump straight to what the central limit theorem has given us. We're going to be looking at the averages, right? The x bar here. X bar will represent, let's say, the average test score, right? The mean. This is the mean test score for groups of size 15, right? They said they took a sample of 15 scores. So say this is the mean test score for groups of 15. All right, so n equals 15 here. Now, by the central limit theorem, since we know the original test scores were normally distributed, this would be the averages, right? The means for these groups of 15 test scores, if you looked at all possible groups of 15, would be normally distributed with a mean called mu sub x bar and a standard deviation called sigma x bar, where the mean of the means is the mean of the population. But again, the mean of the population is unknown. So because of that, we're going to use our point estimate. We're going to use x bar. We're going to use the sample mean. Now they said for the sample of size 15, they had those 15 people they looked at had an average standardized test score of 101 points. So we're going to use 101 here as our initial guess, our point estimate of mu. Again, we don't actually know mu itself though. And the standard deviation of the means, these means for test scores for groups of 15, remember how that was calculated? That was the standard deviation of the population, sigma, divided by the square root of the sample size. Now sigma was given, right? They told us the known population standard deviation of 11 points divided by the square root of the sample size, which was 15. All right, I'll punch this in, approximate it. All right, so let's pull up a calculator. So we have 11 divided by the square root of 15. There, it gives us about 2.84. All right, about 2.84 for the standard deviation. I could draw a little picture. Here's number line here representing different values of x bar, different means I could get for groups of 15 scores. It's normally distributed, so I'm going to draw this symmetrical bell-shaped curve. And under the peak, the value under the peak is supposed to be the mean of the population, but we don't know that. So we're going to use our point estimate here. I'm using the sample mean of 101 as the middle. Now, they want us to create a 98% confidence interval. So that means 98% confidence. So what that means, right, is we're looking for these two values. We're looking for a value above the middle, above 101. So there's 101, plus some margin of error, right, ME. And then the same distance on the other side, right, here's 101 minus this margin of error. And I'm looking for these two values such that the area between them, right, the area under the curve between these two values is my confidence interval, is 98%. All right, so in order to do this, I need to find this margin of error. Now, hopefully you recall the margin of error, from a previous objective, when you're estimating a mean, when you're estimating mu and you know sigma, when we know sigma is 11, remember the margin of error involved a z-score, right? You need a z-score with, what area above it, and that involved that half alpha. So remember, if 98% is the confidence level, remember alpha, the significance level, was what's left over. That would be 2% or 0.02. And if there's 2% left over, then what's the area above this upper value and below this lower value? That's 1% or 0.01. Same thing over here, 0.01, to make a total of 100. So to find this margin of error, to figure out how many standard deviations above and below the mean or this upper and lower value of the interval, I need to know what z-score has 1% above it. That was half alpha. So what z-score has, 1% above it? So that's this z with a subscript of 0.01, half alpha, times the standard deviation, right? Times that sigma over the square root of n. All right. Well, this z-score with 1% above it, you can find that from the table they gave us, right? The z-score with 1% above it, that's this one here, 2.326, right? 2.326. So on my paper, this upper value is 2.326 standard deviations above the mean, and this lower value is 2.326 standard deviations below the mean. So the margin of error is 2.326 times my my standard deviation. The standard deviation for this distribution was 2.84. Well, I'm just going to go to the calculator. All right. Oops, I already had it up. Turn it on there. Now the 2.84 that's already on the screen with the 2.840187787 there, that's the standard deviation already. So I'm just going to go 2.326 times that answer. And here is our margin of error, right? It's approximately, if I go to, they want 2 decimal places. If I go 6.61. So the margin of error when I'm creating this confidence interval, approximately 6.61. So then the upper value of my 98% confidence interval estimate for mu is 101 plus this, so 107.61 for the upper limit. And then the lower limit of this confidence interval, this 98% confidence interval, is 101 minus this. Now, 101 minus 6 would be 95. Then minus 0.61 would be 94.39. 94.39. All right, if you want to double check that with a calculator, I'm just going to store this margin of error as x. So every time I use the number x, the letter x, it's 6.06, 606. So it's the margin of error. So let me take 101, plus x plus the margin of error. There's the 107.61, and then just re-enter this second entry and then change the plus to a minus. 101 minus the margin of error is again 94.39 as I had over here. Great. So there's the lower limit and upper limit of my confidence interval. 98% confidence interval. So I did all that, and I'm entering 94.39 as the lower limit, and 107.61 as the upper limit. So what this means is given my sample here, I would say that I'm, I don't know what the population mean is, right? I don't know what the population mean is, but based on my sample, I'm 98% confident that the population mean is somewhere between 94.39 points and 107.61 points. It's great. And again, read your answer explanations, whether you're right or wrong. right? Read your answer explanations, especially if you're wrong, right? Just to make sure you figure out where you went wrong. And I don't know if there's a second part here. No, there isn't. Okay. So, yeah, so hopefully that helps with that kind of problem. This next one's very similar, but it's 80% instead of 98%. That's really the only difference, right? The confidence level will change, which z-score you use. That's all the confidence level is going to do. It's just going to change which of these z-scores they're providing you're going to use when you create the confidence level. All right, so again, hopefully that helps with that kind of a problem, and thank you very much for watching.